Hello. Today we're going to be looking at using trigonometric ratios in order to find sides of a right triangle. So to do this, we're going to look at a couple of examples to demonstrate how you would solve for the other side. So step one with this, though, will just be setting up the proportion used for sine, cosine, or tangent, depending on the information that's given and what we're looking for. Step two of that process will then be algebra, solving for the unknown. And once you do that, you're all done. Once you solve for the unknown, you have the missing value. So that's it. The only thing that may be different is if this comes from a word problem. You may first have to draw the triangle appropriately. So in this instance, we could say that at an angle of elevation, meaning that we're going up of 30 degrees, maybe we have a ladder that is 7 foot long, and we want to find out how far up the wall the ladder goes. It's a really good word problem that just made up on the spot. But as you can see from that, we have an angle of elevation of 30 degrees. We know the ladder is 7 feet tall, and we know we're looking for how far up the wall does the ladder go. Well, from this, we could draw a triangle, put our 30 degrees, have our ladder be 7 feet, and our ladder would be the hypotenuse in that scenario. Most of you probably can picture that because you've worked with a ladder before. You know how a ladder leans up against a wall. And an x would be our wall because we want to know how far up the wall does the ladder go. Well, so from this point, we then would move on to setting up our trigonometric ratio proportion based off the given information. What do you mean by based off the given information, Professor Stevens? Well, what I mean is we have this angle given here. We know that this side is the hypotenuse. And we know that x would be, it's got to be opposite or adjacent. Which one is it? Well, it's not touching the 30 degrees at all, so this must be the opposite side. Now, what trig ratio uses opposite and hypotenuse? And maybe you're not quite sure at this point, but as you keep working with these, you will begin to become accustomed to using it. But as I told you before, a lot of people use that SOHCAHTOA to help them out with that. And from this, we have opposite and hypotenuse. That's here with the sine. Now, how am I going to use that to solve now? Because I said you have to set up this proportion. Well, we'll set it up. So we get sine of the angle. Now, every time we've done this before, it has been the angle. Well, in this case, we know what the angle actually is. The angle is 30. So we can put the 30 degrees in here. Sine of the angle, or sine of 30 degrees, is equal to the opposite side. It's equal to the opposite side over the hypotenuse. So in this case, I know the opposite side is x, and I know the hypotenuse is 7. So if I want to solve for that, first I have my proportion set up. Sine of 30 degrees equals x over 7. Now, what many of you may be thinking is, I don't know what sine of 30 degrees is. That's okay. You can use a scientific calculator to figure this out. Now, there are many different types that you could use. Sometimes you have to put in the 30 before you hit the sine button. Sometimes you put sine first, and then you enter 30, close parentheses, and hit enter. So depending on the calculator that you're using, you need to find sine of 30 degrees. And I'll tell you what that is so that you are able to correct yourself and see how to answer that correctly. So when you did this, you should have gotten 0.5 for your answer. So sine of 30, you should have gotten 0.5. Now, a couple of things, make sure your calculator is measured for degrees, not radians, before you begin this, because our degree that's given to you is in degrees. If it was given to you in radians, you would have to change your calculator to read radians. But other than that, when you did sine of 30, you should get 0.5. So you need to pause to try to fix things out, or email your instructor or myself to see, hey, how do I actually set this up to give me the correct number for sine of 30. Okay. All right. So now we first have our triangle drawn, or you draw it based off a word problem, if the information given to you. We set up our proportion of sine, cosine, or tangent based off the given information. We see that the angle is 30 degrees. We know that if we label our sides opposite and hypotenuse in this instance, we know that we must use sine because sine uses opposite and hypotenuse. Cosine uses adjacent hypotenuse, and tangent uses opposite and adjacent. So from here, we set up our proportion, or our equation, and we see that sine of 30 degrees equals x over 7. Well, now we can simplify this expression here. Sine of 30 degrees gives us 0.5, and 0.5 equals x divided by 7. Well, how do you solve for x in this instance? Well, we know from algebra that in order to solve for x, we would multiply both sides by 7. And that's going to look a little funky with that decimal looking like that. So I'm going to do it this way. And then we end up seeing then that 7 times 0.5 equals x. Because the 7 divided by 7 will divide to 1. So 7 times 0.5 gives us 3.5, and that's x. And that's what x is. It's 3.5. All right, that was kind of cool. And in fact, if we wanted to, if we have 3.5 here, we can find this other side automatically, right? Because we can use Pythagorean theorem to find that other side. We can also do we can also use a different trig function to find the other side. We could use cosine. We'll look at that in the next example. We'll look at cosine. Okay, so let's do that now. So we're gonna find y. I'm gonna call it y. Okay, so if you need to pause now to see how we found x to be 3.5, you can pause it. But this time we're gonna look for y. So pause it and copy down your information if you need to. Okay, so we have our triangle drawn, and this time we're looking for y. Well, since we're looking for y, let's relabel our sides. The hypotenuse is always going to be the hypotenuse, so we don't have to worry about that. And we're looking for y this time, so I'm not going to worry about x anymore. We already found that. We're looking for y. And if we are looking for y would be, well, we know that's the opposite side because it doesn't touch the 30. So y must be the adjacent side. Okay. So which trig function uses adjacent and hypotenuse? Oh, well, from SOHCAHTOA, we know that cosine uses adjacent and hypotenuse. So cosine of the angle equals adjacent divided by hypotenuse. Okay, so cosine of the angle equals adjacent divided by hypotenuse. I know the angle is 30 degrees, so I'm going to substitute that in. I know the adjacent side is y, and I know the hypotenuse is 7. So once again, we see a very similar setup, but instead of sine of 30, it's cosine of 30. All right, and so if we were to do this now, we simplify this, we get an approximation for cosine. It gives us a lot of digits to work with. Rounding will be up to you. The more digits you have, the more digits you can hold in it, the better. I actually know the exact value of this, but I'm not going to use that. Some of your calculators will give you the exact value of it. You would see square root of 3 over 2. If you see that, then that's cool. Then you can get to an exact answer. If you don't see that, stick to what you see. And so depending on your calculator, you should see 8.66 and maybe 8.660 or something like that. Some of you may have 7 or 12 digits that you get to see. The calculator I currently have right now gives me 4. So I'll put the 4th one. It was a 0, so that's what it rounded to. But this is equal to y over 7. Now, in this instance, what would I do then to solve for y? Well, it's no different from what we just did with sine. We'd have to multiply by 7 on both sides. And then I multiply by 7 here. And then when I multiply by 7, what I end up getting is I get 6.062 is approximately what y is. All right, and I'm putting approximate because I had to round this portion because it didn't give me the exact value for cosine. If I knew the exact value, which I actually do, or if your calculator gave it to you, then you could put equals because you know exactly what it does equal. It's important to note here at this point how many significant figures you're asked to round to, or how many digits are you asked to round to. It said 2 different things there: significant figures and how many digits they tell you to round to, or what place value they tell you to round to. Do not round until your final answer. if my calculator gives me those 12 digits, I would most likely keep those 12 digits and then just multiply by 7 and then round at the end. Always round at the end. Don't round early, because if, for instance, it said to round to the nearest whole number, you put a 1 here, now you get 7 times 1, and that's 7. This is not 7. This is very far away from 7. And if I were to say, oh, well, that's just 7, that wouldn't be the hypotenuse anymore. Our angles would be all different, and we wouldn't be able to get a right angle. I'd be better off estimating this as 6, which I would get if I waited to the end. Okay, so don't round until the end. All right, well, that would be an example with cosine. Now let's look at an example with tangent, and let's change things up a bit, shall we? So I'm going to erase now for this cosine example. So if you need to copy it down, please go ahead now and pause and copy it down. All right. So I'm going to also change the way the triangle looks, because I feel like people get in the habit of drawing it that way or seeing it that way on problems. And your triangle is going to look like all kinds of different turns and rotations from just that standard right triangle that most people tend to draw. So I'm going to change the way it looks so that you don't get used to, oh, it must be like that. If not, I don't know what I'm doing. Because you do know what you're doing. It's still a right triangle. So I'm going to put my right triangle there. And I am going to actually call this side 2. And I'm going to say this is 45 degrees here. Okay? And I want to find this side here. Okay? All right. So first things first, you draw your triangle. It's already drawn for us here, so the information is already given to us. But now what I would like to do is I want to find x. Well, I need to set up a trigonometric ratio, a proportion or equation, in order to solve for x. Well, how do I do that? Well, let's first label the sides to see what kind of sides are given to us. Do we have opposites? Do we have the adjacent side? Do we have the hypotenuse? Let's find out. So the hypotenuse we know is here because it's opposite of the 90 degrees. It's the side that doesn't touch the 90-degree angle. Our opposite of the 45 will have to be x, because it's the side that doesn't touch it. And that makes 2 our adjacent side. So in this instance, we're given the opposite and the adjacent side. Okay, cool. So which trigonometric function uses opposite and adjacent? Oh, it's right here. It's tangent. So tangent uses opposite and adjacent. So we're going to do tangent of the angle is going to be opposite over adjacent. And as you move forward with these and you keep practicing this, you're going to skip this step and go straight to setting it up. And that's what I expect for you to do. So if you went ahead and did that this time, that's great. So tangent of the angle, what's the angle? It's 45 degrees. So I'll get tangent of 45 degrees equals the opposite side, which is x, over the adjacent side, which is 2. Okay, great. Well, if I take tangent of 45 and I plug that into my calculator here, I should get 1. So tangent of 45, and I do get 1. So I get 1 equals x divided by 2. All right. Well, great. How do I solve for x? That's right. I multiply both sides by 2. Okay. And I end up getting that 2 equals x. So this is 2, and that side is also 2. Oh, what kind of triangle is that? Well, it's a right triangle. Yeah, well, what kind of right triangle? You have 2 sides of equal length of 2. Oh, that's an isosceles right triangle. That's right. This is an isosceles right triangle because it has a right angle, and these 2 sides are congruent in measurement. What does that mean about these angles then? They also have to be congruent, and if we subtracted 90 from 180 and subtracted 45 from that 90, we would end up with 45 degrees here. So we would have seen off the bat that, hey, these are isosceles, so I know the other side has to be 2 to begin with. But we use the trigonometric ratio in order to prove that. That's cool, right? Okay, well, great. I'm going to show you one more example, because all of the examples we have seen thus far all are solving for the numerator. So let's change things up a bit here. We're going to actually find y. Okay, so we're going to find y now. So y would be the hypotenuse, of course. Okay. And does it matter what trig function we use? No. We were still given information about the adjacent side first, so we'll use the one that uses adjacent hypotenuse. We'll use cosine. So I'm going to erase this. So if you want to pause, go ahead. Okay. So let's see what we get for the hypotenuse in this instance. So we could take cosine of the angle, and that's going to be equal to the adjacent side divided by the hypotenuse. So cosine of the angle will equal the adjacent side divided by the hypotenuse. Okay, well, great. The angle is 45, so we're looking at cosine of 45 degrees equals the adjacent side, which we know is 2, divided by y, which is the hypotenuse. Okay, that's great. Now, how do you solve for y? Okay, well, maybe first let's find cosine of 45. And so if I do cosine of 45 degrees, what I end up with is an approximate 0.7071. Okay. Okay. All right. So, because that's as far as my calculator goes, if yours goes further, you may want to use further. Or if you get the exact answer, use the exact answer, square root of 2 over 2. Okay. So, in this instance, still, the question is, how do we solve for y? It's in the denominator. Have you seen that before? There was an example that, in the solving using division. And there was also an example in solving complex equations. And this would be, some people consider this a very complex equation. It's still one step, really. So how do we solve for y? Well, there's a couple of ways that you can think about this. Let's say that this number was 1 over here. 2 divided by what gives you 1? If that was the question, many of you would say, oh, that's 2. I know that. Well, how do you know that? Because if I do 2 divided by 1, I get the answer. And that's right. But to show you that how we would solve it algebraically, normally you would just multiply by whatever the denominator is, right? Well, let's do that here. Let's multiply by y on both sides. And when we do that, we end up with 2 equals y times 0.7071. Well, how would you get rid of the 0.7071? You would divide by it. Okay? And so y would equal whatever we got if we divided those two numbers. So if I did 2 divided by the 0.7071, I would end up with 2.828. That's what I end up with, 2.828. Okay, or 2 square root of t. So depending on what you got going on there. So that's what I end up with y is. I end up with 2.828. So let's see. Make sure. Okay, so we just solved for the hypotenuse. So what's important here to realize is that when the denominator is what you're solving for, essentially you're just swapping places here. These swap places. This y and what was up here swap places. See, this y was down here and a 0.07 was up here. They swap places because now we're dividing by it and solving for y. So a lot of times people will teach that when what you're looking for is in the denominator, you swap places. When what you're looking for is in the numerator, you just multiply both sides by the denominator. So whatever you need to do to remember that so that you can solve it, do it. I tend to show people the algebraic approach, but I mentally think of, well, if this was like 9 divided by what number gives me 3, I would just do 9 divided by 3 to find out what the answer is. So that's using principles of division. So all right, so that's how you can use a trigonometric ratio in order to find a side of a right triangle. And we will look at finding the angles next. I will see you soon.